Okay, everybody, this is the 2011 Math FRQ review. This is one of my favorites, actually. Take a minute to pause this video and practice this problem, but I will read through this. Today we'll be covering Part C only because this is our math review, and I want to focus on this. So this says, coral reefs are produced when corals acquire calcium ion Ca2 plus and carbonate ion CO3 2 minus from seawater and deposit solid CaCO3 in the form to form their exoskeletons. Scientists are concerned that relatively rapid decreases in ocean water pH will hinder the deposition of CaCO3, calcium carbonate. The graph above shows the amount of carbon dioxide dissolved in the ocean water, and ocean water pH shown in parentheses since 1850, and the predicted changes through 2000 or 2100. So as you can see here, we see pHs. We have our pH is decreasing, and but we have this dissolved calcium carbonate. We see micrograms per kilogram, and we see this is increasing. All right, so what we need to do is explain how an increase in the amount of dissolved CO2 in ocean water results in a decrease in the pH of ocean water. Explain why the movement of the carbon into the ocean has been increasing since 1850. Okay, now here's where we're going to focus our time. In order to model the effects of ocean acidification on coral reefs, some simplifying assumptions can be made. The assumptions in the table below use the assumptions in the table below to perform the calculations that follow. Assume that the total global area of corals growing in reefs is 2.5 times 10 to the 11th meter squared. Now, this is area of coral in the total area in our oceans. Assume that corals grow only vertically, and that the average vertical growth rate of corals is 3 millimeters a year. Okay. Assume the average density of calcium carbonate in corals is 2 times 10 to the third kilograms for every meter cubed. So our first is to calculate the current annual global increase in volume in meters cubed of calcium carbonate in coral reefs. Show all steps in your calculation. Then calculate the current annual global increase in mass in kilograms of CaCO3 in coral reefs. Show all steps in your calculation. Because of ocean acidification, it is expected that in 2050, the mass of CaCO3 calcium carbonate deposited annually in coral reefs will be 20% less than is deposited currently. Calculate how much less calcium carbonate in kilograms is expected to be deposited in 2050 than would be deposited if ocean water pH were to remain at its current value. Identify and describe one likely negative environmental impact of the loss of coral reefs. Identify one environmental problem other than one due to ocean acidification or loss of coral reefs that affects marine ecosystems on a global scale. Please pause now and try as much of this problem as you like, but be sure to focus on Part C. All right, so current annual global increase in volume in meters cubed of calcium carbonate in coral reefs. Well, volume, meters cubed, that's the unit we're looking for. We don't have anything like that, but we have something similar. We have meters squared per area, which is length times width. Volume is length times width times height, okay? Corals grow vertically. Well, that sounds like height. The only issue is that this is in millimeters instead of meters. So if we were to convert this into meters, we can multiply 1m, or m to the first power, by m to the second power to get m to the third power. So let's see what this looks like. Meters cubed is equal to meters squared times meters. So this is our key right here. So 1 meter is equal to 1,000 millimeters. Millimeters are quite tiny, and there are 1,000 of them in 1 meter. All right. So if we have 3 millimeters per year, okay, times 1 millimeter over 1 meter over 1,000 millimeters, okay, we will be effectively canceling out our meters units, leaving the year and meter units behind. Now, we're multiplying whatever this is by meters squared. Now, will this give us the units we want? Yes, we're not canceling anything out. What we'll effectively have, since meters are canceled out, or millimeters are canceled out, we'll be left with 1 meter meter to the first power times meter to the second power equals meter to the third power. So 3 times 2.5 is 7.5. And that's 10 times 10 times 10 to the 11th meters cubed. Okay, now I've just multiplied across here. The only thing is I have not divided by 1,000. Now, when you're dividing by 1,000, for every 10 space in the denominator, you subtract 1 from the exponents. So we have 11 times 10 to the 11th power. So this will actually be 11 minus 1, 2, 3 is 10, 9, 8. 7.5 times 10 to the 8th meters cubed. It's a little fuzzier, but we have millimeters per year times meter over 1,000 millimeters. Millimeters cancels out, leaves me with meters. Now, meters times meters will be meters squared. These are the units I'm looking for. These are my breadcrumbs to take me to the correct answer. 3 times 2.5 is 7.5 times 10 to the 11th meters cubed. I'm sure I could have done this all just in one go, but I don't because I like to be careful, and it saved me from certain mistakes. So I have 3 decimal spots here, right? So when you're dividing with exponents, if you have just tens places you're dividing by, you subtract. In this case, I'll subtract by 1, 2, 3. And this gives me 7.5 times 10 to the 8th, because 11 minus 3 equals 8 times 10 to the 8th meters cubed. All right, so I've got the volume of calcium carbonate from coral reefs per year. Calculate the annual global increase in mass in kilograms of coral reefs. Okay, so I've got the volume. All right, now how much does this weigh? I know the density of coral. It's 2 times 10 to the third kilograms for every cubic meter. Every cubic meter of coral will weigh this much, and I know how many cubic meters I get every year. All right, so what will I need to do? I'll have 7.5 times 10 to the 8th meters cubed. All right, and basically I'm going to set this up so that I cancel out meters cubed with meters cubed on the bottom here. All right, sorry, that should be meters caret cubed, right? Times 2 times 10 to the third kilograms per year per meter cubed. All right, so basically what I've got when multiplying exponents, you add them together. When we divided earlier, we subtracted, but now that we're multiplying, we add them together. So I have 2 times 10 to the third in the numerator, and I have 10 to the 8th in the numerator. All right, so what I'm going to get is 15. So 7.5 times 2 is 15. 10 to the 8th times 10 to the third is 10 to the 11th kilograms. The only problem is this can't be our answer because this is not correct scientific notation. We need 1 and then a decimal, one whole number and then a decimal. So if we move the decimal over 1, we're in fact adding a number to here. So instead of 10 to the 11th, it'll be 10 to the 12th. 15 times 10 to the 11th kilograms is equal to 1.5 times 10 to the 12th kilograms, and that's our correct answer. 7.5 times 10 to the 8th meters cubed calcium carbonate times kilograms per meters cubed. Meters cubed cancels out, calcium carbonate cancels out. Kilograms of calcium carbonate. All right, so that's 15 times 10 to the 8th plus 3, because 3 and 8. So 15 times 10 to the 11th. All right. Now 15 is not appropriate. We need to move a decimal over 1 to make this smaller, which means we need to make this a little bigger, right? So 1.5 times 10 to the 12th kilograms of calcium carbonate for every year. Okay, so this one's a little different. It's tricky. It's saying that because of carbonic acid, which is carbon dioxide that's been dissolved in ocean water, which is acidic, we're dissolving calcium carbonate. So it's expected that by 2050, the mass of calcium carbonate deposited annually will be 20% less than is currently posited today. Calculate how much less. Now that's a tricky one. This is not how much, it's how much less calcium carbonate in kilograms is expected to be deposited in 2015 than will be deposited today at its current value. All right, so what we have is what we know. 20% is really just, I'm going the long way about this, but 20% less, okay. 20% less than 100 is 0.8. Now, you could just do 0.2, be a little easier. I'm going to go the long way. All right, so 0.8 divided by 1. All right, 0.8 divided by 1 is equal to 80%. All right, so we multiply this. It tells us how much is going to be deposited. If this helps, 80% is also 4/5. This is screwy, so forgive me. So 1/5 of 15 is 3, and this makes sense. 3, 6, 9, 12, 15. Okay, so if anytime you have 20%, you're basically having like 1/5 or 5 small parts. Okay, so 1.5 is what this or 1/5 of 1.5. Sorry, that's what that should say is 0.3. So I apologize for that little typo. Okay, if you have 4 of 0.3, this means the same as 0.3 times 4, which is 1.2. So really, what is being deposited in the year 2050, based on our calculations, we should expect 1.2 times 10 to the 12 kilograms every year. Is that what the question is asking? I don't really think so. The question's asking how much less. It's not how much, it's how much less. Okay? So this is what's being deposited today. This is what's expected to be deposited today. How much less is that? So 1.5 times 10 to the 12 kilograms per year minus 1.2 times 10 to the 12 kilograms per year is equal to 0.3 times 10 to the 12 kilograms per year. Well, that's not correct scientific notation either. We should have a whole number here that's not 0 as our decimal place. So 0.3, if we move this decimal place over, we're going to make this a little smaller, right? So 0.3 times 10 to the 12 kilograms per year is equal to 3.0 times 10 to the 11th kilograms per year. And here's our, what do you call it? Our math here. 1.5 times 10 to the 12 kilograms per year times 0.8. That tells us how much is being deposited. All right, times 10 to the 12th, but how much less than this number? 1.5 minus 1.2 is 0.3 times 10 to the 12th, because this hasn't really changed. And if we need to make this correct scientific notation, we need to move this over and make this number a little bigger, which means we make this number a little smaller to balance things out. So 3 times 10 to the 11th kilograms every year. Here's the complete work. I hope this was of value to you.